Okay. Last example kind of ran out of time, but do want to point out that in this example, the correct final answer would be, and we can kind of look at it right here. The correct final answer that you would write down would be to take 0.5844 grams of sodium chloride, which actually with sig figs should only be 0.584. Actually, I had one too many sig figs in there. So 0.584 grams of salt, and then enough water to get to 100 milliliters, or about 100 milliliters, because the salt itself is going to have some volume. So the most correct answer would be 0.584 grams of salt with enough water to get to 100 milliliters. So that would be the most correct answer. Okay, so I want you to try this example 24 right here. And so pause the video, try that on your own, and then start the video back up after you have given it an attempt. So go ahead and try this example 24 in your notes. Okay, so hopefully you had a little time to do that. So here we go. It is another how would you prepare question. So we are going to prepare a 2.5 molar solution. And so it's like, all right, so we see this M, right? Like this new thing. There's the molarity. And so then that hopefully is routing you to this idea that, oh, molarity equals moles divided by liters. So let's go ahead and set that up. We have, oops, sorry, I did that again. That's not going to work. We have the molarity. So I need to write down 2.500 molarity. So I know the molarity. And then I know the milliliters. And so hopefully you are like, okay, I know that milliliters aren't going to work. So that good chemistry student goes ahead and converts that over. So divide by 1,000 becomes 0.500 liters. So I'm going to go ahead and plug that in here because we want liters to interact with the molarity, because that is moles per liter, not moles per milliliter. So I'm going to convert that. And then we're going to solve for x. And so that's pretty straightforward. And so x is going to give us some moles. So let's go ahead and do that. So solve for x. So 2.5 times 0.5, rock and roll, 1.25. 1.25 moles of K2CrO4. Okay, now the problem is that we're not going to have the ability to put moles into a container. We can put grams in, we can't put moles in. So we're going to convert this over to grams. So 1.25 grams of the K2CrO4. And then we're going to go ahead and convert that into grams. And so we're going to add up K2CrO4. So hopefully you did that. So 39.09 for the potassium, and multiply that by 2. And then add the chromium. And so the chromium is 52.00. And then add that to the 4 oxygens. So 16 multiplied by 4. And then we're going to get 194.18. So that 194.18 is going to help us get to grams. So 194.18 grams. And I did make a mistake over here. Need to fix that. That should say moles. because we're just using that right there. So 194.18 grams for every 1 mole. And we're going to run that through. And so going to take that times 1.25. Actually, I think I'm going to change that because from sig, yeah, that should be fine. So no, that's fine. 1.25 moles. I was looking at the sig figs, but with the 3 sig figs here, I'm going to get an answer of 243 is what I got. 242.725, but I'm going to round that to 243 grams of this potassium of our K2CrO4, all right? And so with our potassium chromate, and then it says, how would I prepare? So how am I going to make this? What I'm going to do is I'm going to take 243 grams of potassium chromate and enough water to get to 500 milliliters. So it's the grams and then the 500 milliliters of water, or enough water to get to 500 milliliters. So what we're saying here is that, kind of go down here, is if you have a container, so here's your container, and in your container you put the solid. So like the solid's going to be down here at the bottom, right? So here's your solid. So there's your solid chemical. So what happens then is then you add your water, and your water goes up to that 500 milliliter line, and then you shake it up and dissolve it, and then you have your solution. So that's how you would make it, and that's why I keep saying enough water to get to the 500 milliliter mark. So hopefully got that one right. So this one, calculate concentration of a 0.4 molar solution of sodium carbonate in grams per liter. So this is really just understanding units. Real quick, so we want to understand that this thing here means moles per liter, and this means grams per liter. So that's all we're doing, is we're converting from one unit to another. So let's go ahead and do that. 0.400, and I've got moles per liter. And if I want to convert that over, so it's moles per 1 liter, this is going to be grams per 1 liter, then let's just go ahead and get rid of our moles. Remember, top and bottom. And this was Na2CO3. So we're going to add that molar mass up. And so we've got some sodium. And so that's going to be 22.99 times 2. And then add it to a carbon. And then add that to 3 oxygens. We're going to get 105.99. So 105.99 grams. Okay. So I've been a little lazy on this, but moles should be canceling, and they are. So it's going to give us grams. So we're going to multiply that by the 0.400, and I'm going to get 42.396. And so when we'll run, made a mistake here. I wrote this down wrong over here. So I need another 0 in there. Not the best today. Keep missing things. So let's go ahead and fix that. And then this is going to turn into like a 4.2. So a difference of 10 is significant. So I want to get that right. There we go. and that's too many sig figs. This has 3, so let's just take this down to 4.24. Looks like 4.24. So get rid of that guy. There we go. So it's 4.24 grams per liter, or grams decimeter cubed. So that is just a conversion. This is just a conversion. It's using the new concept of molarity. That's all this is. And so it's just, I just want you to understand that that is molarity. And that if you know that, then you can just use some basic conversions to get your unit into grams per liter. So, all right, let's check our time. All right, I'm going to go ahead and go to the next one. I got enough time, I think I can squeeze that one in. And so this is a dilution problem. And these are pretty quick. So the way you know it's a dilution problem is you're going to see one chemical and it's going to have 3 variables: volume of hydrochloric acid, molarity, and volume. So we've got an M, or a concentration. So we're looking for an M, a first molarity, and the volume that goes with that. And then the new molarity and the volume that goes with that. And so it says determine the concentration. So we're looking for molarity. And we've got 75 milliliters. And so one of the things that students always have to see is these two are linked. So they go together because they are happening at the same time. So I'm going to put them together. But this is in milliliters, so I'm going to make it liters, so it works out nice. So 0.075, just divide it by 1,000 liters. And I'm going to multiply it by the molarity. So there's the two that go together. So they're on the same side. And then we've got the new volume. And that's going to be 0.300 liters. And then they want to know, okay, well, what's this new concentration going to be if I dilute it? All right, so now it's just solve for x. So I'm going to go 0.75 and then multiply it by, 0.075 times 0.4 and divide by 0.3, and I'm going to get 0.1. So the molarity has gone down. See, it was 0.4, and now the new molarity is 0.1, and that makes sense because we diluted it. And so it's just making sure that these two pieces, which are up here together, are together, and then the other two pieces, which include the x or the unknown, are together. And honestly, it doesn't matter which side you put them on as long as the ones that are together stay together.